Hello everyone, welcome back to the video lecture on basics of electrical and electronics engineering on the topic reverse biasing of PN junction diode. So far we have discussed about the forward biasing of the PN junction diode and also about the construction of PN junction diode. So in this video we'll look at about how the reverse biasing is going to take place in a PN junction diode and what are going to be its characteristics in the upcoming video. So here in the forward junction diode, as we saw that the p-type material is connected to the positive terminal and the n-type material is connected to the negative terminal. Also we can say that in the p-type material the majority charge carriers are holes and in the n-type material the majority charge carriers are electrons. Now in the reverse bias junction the p-type material is connected to the negative terminal of the battery and the n-type material is connected to the positive terminal of the battery. Comparing with the forward junction or the forward biasing, we can remember that the depletion region or the width of the depletion region, the barrier potential actually decreases when the biasing is done. When that decreases across the junction, the carriers, the majority charge carriers, starts moving towards the other end, thereby contributing to the flow of the current. But here you can clearly see that the p-type material is connected with the negative terminal, which makes the holes to get attracted towards the negative terminal, and also in the n-type material being connected to the positive terminal of the battery, the electrons gets attracted towards the positive terminal of the battery. So this can thereby cause or result in the increase in the potential barrier, or it prevents the flow of the majority carriers across the junction, because here the depletion width actually increases its width rather than decreasing its width. So this increase in its width can seriously cause the prevention of the flow of majority charge carriers. But still you can see a very little flow of the minority carriers, that is the holes in the n-type material as well as the electrons in the p-type material, which are called as the minority carriers, will definitely contribute to their flow across the junction. So this flow of the minority carrier will not result in very huge flow or the contribution to the conduction of the current, but yes, there will definitely be the flow of minority carriers across the junction of the PN junction diode whenever it is reverse biased. So in reverse biasing, when the voltage is applied across a diode in such a way that the diode prohibits the current and the potential barrier also increases. Now the reverse bias condition is coming into effect. So how far can the diode withstand this reverse bias condition? So here the junction resistance as well as the potential barrier increases. Also, when the reverse voltage is increased beyond a value called the breakdown voltage, then the PN junction cannot withstand its strength and hence it breaks down permanently or it gets destroyed permanently. This can also increase the reverse current, and the reverse current starts to increase very sharply. But this can never contribute to the flow of the current properly in the forward direction, and hence it cannot be also employed for the usage in the application. So generally a diode is said to act like a closed switch in the forward bias condition and as an open switch in the reverse bias condition. Thank you.